Hello, welcome to Analog Output. Welcome to Analog Output. I'm going to show you how I turned one of these into a synthesizer module. So this is a toy voice changer megaphone. Yeah, it's got a trigger you pull and you talk into a microphone at that end, and sound comes out that end, and it's modified by various means controlled by various switches on the side. And these things have been around, I don't know, 15, 20 years, maybe more on the market. And circuit benders have been playing with these things for, I don't know, 15, 20 years, maybe more. And a few months ago, I saw a video from a guy called Soundbender, who had taken one of these things and took the circuit board out of the megaphone and mounted it in a box with input and output jacks and various circuit bends, and had turned it into a kind of a crazy effects box. And then I saw another video by Simon the Magpie where he took the circuit board from one of these things and made it into a guitar pedal. And I said, links to those videos, I'm going to put them down there. I said, that's pretty cool. How about taking one of these things and turning it into a synthesizer module? So I went on Amazon and I found that they were selling these things at Amazon warehouse for just over $5 each at the time. I don't think they're selling them for $5 each anymore. I think you have to pay like $13, $15 for them now. But at the time they had them for $5. So I said, well, I'm not going to buy one. I'm going to buy two, because I will probably fry one of them in the process of just trying to figure out what to do with it. So I bought two and took one apart and started messing with it and made it into a synth module and didn't fry it. So, you know, I still have this other one left over, which I don't know what I'm going to do with it, but at least we can use it for a prop right now, right? Anyway, let's take a look inside this thing, shall we? Here we are. Took out the battery. This thing's held together with screws. Let's unscrew this thing. So here we have it open. There is a trigger. And this trigger, all this does is it closes a connection to connect the battery to the board. And there's our printed circuit board. Okay. Now, let's take this thing out. There's the other side of the circuit board. So, bunch of through-hole components, very nice for circuit bending. And of course, the main job of this thing is handled by a sound chip, which is hidden away under that blob there. So there is a microphone, connects here. There's a speaker, which connects there and there. There's a bunch of LEDs which connect there and this is the connection to the battery power. On the circuit board itself, you've got your switches, just 5 switches that all they do is they connect or disconnect various pins of the sound chip to ground. And then there's one other important item, which is this resistor right here, which is marked 16K, I think. And that is a pitch resistor. So that's the board. What do you do with it? Well, for one thing, of course, we don't want to run this thing off a battery. We want to run it off the synthesizer power supply. So we're going to cut that wire here. And this wire is going to be connected to a 9-volt voltage regulator, which connects to the synthesizer power supply. We're not going to use the microphone, so the microphone gets cut off. And what I did was I connected an input jack on the front panel of the synthesizer module to an op-amp buffer and then a voltage divider, which reduced the signal down from synthesizer signal levels to the signal level that this thing wants to handle. Likewise, we don't want the speaker, so cut the speaker off and connected up the output of this thing. The output comes from this chip here, which is an LM386 audio amplifier. And that thing expects to drive a speaker with an impedance of like 8 ohms or something like that. So what I did was I connected this to a 10 ohm resistor and then connected the voltage from there to an output op-amp gain stage, which brought the signal back up from these signal levels here to synthesizer signal levels. And then the output of that goes through a potentiometer with the other end connected to the input signal. And you take the output of the potentiometer and send that to the output jack. So that gives you a control, a knob by which you can vary the wet-dry mix. You can have it all the input signal or all the output signal or some combination thereof. The other thing that happens is there's a connection from that output back to the input. This is something that I added in. It goes through a potentiometer as a voltage divider. And what that does is it allows you to take some portion of the output signal and feed it back to the input. So you get this feedback loop, which does bizarre and interesting things to the sound you're putting through. There's also 8 LEDs here, which is 8? No, 6. There's only 6. Seemed like 8. Anyway, too many LEDs. So I just cut off all of the LEDs except for one. I kept one LED for old time's sake and put it on the front panel of the synthesizer module. The switches, well, I just left those switches in place. Too hard to try to remove them. I left them in place, set them all to the off position, and then wired up 5 new toggle switches on the front panel in parallel with those switches there. And then the one other remaining thing is this pitch resistor. This is a classic circuit bend hack. This resistor here governs the speed of the sound chip. If you make the resistor larger, it slows the sound chip down. If you make the resistor smaller, it speeds the sound chip up. And that means if you slow the sound chip down, then any sounds that it tries to synthesize will come out at a lower pitch. If you speed it up, the sounds it makes will come out at a higher pitch. So by replacing that pitch resistor with a potentiometer, that gives you a knob by which you can control the pitch of the sounds that this thing produces. And this is like circuit bending 101 basic hack people do all the time. So we've got that here. I took that out, I replaced it. You need to have a fixed resistor in series with the potentiometer, because you don't want to run the resistance down to 0. You'd probably fry the chip if you do that. So there's a pot and a fixed resistor in place of that thing, giving you a pitch control knob. The other thing is there is a Vactrol in parallel with that potentiometer. And for those who don't know what a Vactrol is, it basically is a chunky component down inside of which are two parts. There's an LED, and it's butted up face to face with a photoresistor, a light-dependent resistor. So if you change the current going through the LED, it changes the amount of light it gives off, which changes the resistance of the photoresistor. And if the photoresistor is in parallel with that potentiometer, then it changes the pitch of the sound chip. So this gives you a way to do a kind of quick and dirty, very crude but usable kind of control voltage over the pitch of this thing. And the sort of simplest way you might think of it to do that is just take a control voltage, put it through a series resistor and through the LED, and drive the LED that way. Not really a good way to do it. The control voltages on a modular synth aren't intended for doing things like driving LEDs and powering anything. They're just supposed to be reference voltages. You're not supposed to be drawing much current off of them. So what I did was I created a little op-amp circuit where the op-amp is providing a constant current for the LED, and the amount of that current is controlled by, although not provided by, the input control voltage. So altogether, the added circuitry looks like this. So here is the module, and there's the megaphone circuit board there mounted inside. You can see there's a bit of ribbon cable here connecting these switches here to these switches here. And then pretty much everything else connects to this circuit board back here. And if that circuit board looks familiar, it ought to. If you watched the last video I did, this is another one of those prototyping boards. Same one that I used for the positivizer module. And it's just about big enough for this thing. If I had a much more complicated circuit, I wouldn't have been able to fit it, but it worked out pretty well. That's the Vactrol. It's got 2 leads on one side for the LED, 2 leads on the other side for the light-dependent resistor. This is an op-amp chip. It gives us our 4 op-amps that we use for like buffering the input and the output and lighting up the LED and all that. Molex connectors connecting the output jacks and the potentiometers to various points here. There's a couple trimmer resistors for adjusting various gains. And that's about it. And, you know, I think the number of components on this side here probably exceeds the number of components on that side. I haven't actually counted. But this project is kind of a weird amalgam of circuit bending and synth DIY. You know, and when you're doing making synth modules, you want to be careful to make sure the inputs are protected so that if somebody plugs something weird in, it doesn't destroy your circuit. You want to make sure the outputs are protected so if somebody plugs it into something weird, it won't destroy your circuit, or it won't destroy whatever it is they're trying to plug into. And you're trying to do everything in a nice, careful, controlled way because you never know what people are going to connect to. Circuit bending, you're saying, hey, let's see what happens if we connect this to that. Ooh, how about if we connect that to that? And it's a very different mindset between the two. And doing this kind of amalgam of the two is kind of a certain amount of cognitive dissonance involved. So you end up with this rather elaborate scheme here, which is, I think, Not the typical sort of thing you'd end up if you were trying to just do some circuit bending, but it's appropriate in this case, I think. Anyway, that's how it all goes together. It's mounted on a bracket here that's kind of angled because it's a little too wide to go parallel to this front face, and it's a little too deep to go perpendicular, so it goes in between. And that is how the Megamodule goes together. So let's take a listen to it. So that is the Megamodule. Hope you enjoyed that. If you'd like to take a look at some schematics and stuff, there's a link to GitHub repository down there in the description. Upcoming videos, I've got kind of an interesting percussion module coming up that I'll be showing you. And also I'm starting on a whole new synthesizer from scratch, ground up. And I think you'll want to stay tuned for that. There's a subscribe button over here. I keep pointing that out to you. If you haven't found it by now, I don't know, but it's there. Take a look, you'll see it. Hit the subscribe button and you'll be able to keep track of analog output. And stay tuned till next time. See you then.